This is the Algebra 2 video lesson for section 7.5, exponential and logarithmic equations. The objective here is to solve exponential equations. So what we've learned so far in chapter 7 is everything we can about exponential and logarithmic functions so that we can get to the point where we can solve equations. So the first type of problems are going to be the ones where we just solve for the same base. So here, hopefully you notice the 16 and the 2, you can rewrite them as base 2. So, right, 16 is 2 to the 4th. So we can just change that 16 as 3 to the x. And then the 8 is 2 to the 3rd. So then we know power of a power. We can multiply those. This is 2 to the 12x equals 2 to the 3rd power. And when we have the same base, you can just set the exponents equal to each other. So we can just set 12x equal to 3, divide by 12, and x is, divide this by 3, divide this by 3. This becomes 1/4. Okay, and you can even check in your calculator, right? 16 is 3 over 4. 16 to the 3 over 4 power should be 8. Yep. Okay, and it's just useful to check that stuff. Okay, so try this one on your own. See if you can figure out how to rewrite these with the same base. And then rewrite it with the same base, get it to that base with the exponents, and then set your exponents equal to each other and solve. So try this on your own, press pause, and then check back for the solution. Okay, so here, hopefully you saw that you could rewrite this as 3 to the 3rd, and this is 3 to the 4th. And so x is 4 over 9. Okay, but so they don't always work out that easily, right? Those are just the ones if you notice, and you don't even have to do it that way once you learn this way. Okay, so anytime you have an x in the exponent, or your variable that you're solving for in the exponent, remember that property of logs where if you had an exponent here, you can pull that 3 down like that. What's great about that is you can bring that down by taking the log of both sides. So that's really what logs are great, right? It's saying what's the exponent? And so you can pull that down by taking the log of both sides. So this step here, to get your x down, we're going to take the log of both sides. So we're going to write a log of 15 to the 3x equals log 285. Okay, and so because of our properties of logs, this 3x can come out to the front. So we can rewrite this as 3x times log to the 15, or sorry, log 15 equals log 285. Then we can divide both sides by log 15. And then, right, this is 3x equals, and then in your, I guess we can actually just use log 285 over log 15. And then you just divide these both by 3. So x equals log 285 over 3 log 15. You can leave the answer like that. That's the exact answer. Or you can just put it in your calculator. If it says to round to the nearest, usually say 10,000th, which is 4 decimal places. That's because logs can be really tricky. If you change one little number, it really throws everything off. So if you do log 285 divided by log 15 back up here, you could also have just solved this here, 2.0873. Right, if at this step, if you could set it equal to that, then you just divide that by 3, or you can write it like this with your parentheses in your calculator. This is about 0.6958. So this is your answer. And if you plug that back in up here, like 15 to the 3 times 0.6958, you'll see it gets really close to 285, but it's 285.08. It's not exact, so that's why this is really finicky. That's why this is your exact solution. Okay, either is fine for this. Really what I want you to learn is that in order to solve these, when the variable's in the exponent, you have to take the log of both sides. So why don't you try that with this one here. Take the log of both sides, use your property of logs to move that 2x on the outside, and then get that x alone. So press pause and then check back for your answer. Okay, and this rounds to about 1.5122. If you take the log both sides, move the 2x, divide by the log 5. I did the math here first before I divided by the 2, which is fine. And you might be off by decimal here if you did this, but this is as close as you can get to this is good. Okay, and then problem 3, I'm going to show how to solve using Desmos. So let me bring that in. So what you're going to do in Desmos is you're going to put this into Desmos, y equals 4 to the 3x as one equation, and the second equation is y equals 6,000. Okay, and then it's going to graph these things, and you're going to find the point where they intersect. Okay, and it's going to be up by 6,000. So make sure you have to move your Desmos all the way up there to find the point. Find the point, it will give it to you. The book wants you to do it with your graphing calculator. This is an old book, and they didn't have Desmos back then, and so they tell you to round to the nearest 10,000th, like they did here with 4 decimals. This graph on Desmos does not show it to 4 decimals. I think it's just 2 or 3, usually 3. So just whatever it shows here, that's enough. Okay, let me go get it. Okay, so here I put this in Desmos. Actually didn't need the y equals here, but you did for this, and it draws the line here, and then you kind of just have to search for, bring your viewpoint all the way up to the 6,000, and you can see, click on this point, and you get that your x is 2.092. All right, and you can check that, right? Put 4 in a calculator or in Desmos, 4 to the 3 times 2.092, and you can see it gets close to 6. This is actually 6,005. So if you actually put this in, you can see that's why they want this to be even 4 decimals, because even just being 3, it's not that accurate, right? This actually equals 6,005, which isn't exactly 6,000. So this is, again, just an estimate. And so I do like to do these squiggle lines because it is not exact, right? That's as close as we're going to get using Desmos. Right, but I do want you to know that you can use it that way. And I'm not going to make you try this one on your own. Okay, moving on to word problems. This says, what is sustainable, renewable, natural resource when you manage? Well, your lumber company has 1.2 million trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? Okay, so to come with this, right, you're going to, you're starting with, let's put this in millions, 1.2 million trees, and you're going to harvest 0.7. So after 1 year, you're going to have 1 minus 0.07, right? And then that's after 1 year. Then another year, you're going to subtract, you're going to multiply that by that, 7% of that. And then 7% of that, you're going to subtract, right? So what's happening here is the amount of years is going to be, however, each year you're going to multiply by this number here. So the equation is 1.2, and then let's do this 1 minus 0.07. You're going to have 93% of your trees left after 1 year, after 2 years, blah, blah, blah. Let's make t your years. So however many years you have, you're going to be multiplying by 2.93. Okay, and then how many years will it take to harvest half the trees, right? We want to know when does this is our amount of trees we have, right? When we start at t as being 0, this goes to 1, we have 1.2 million, right? And then 1 year after that, we have 93% of those. Half of that is 0.6, right? So when does this equal 0.6? All right, so this is the equation we are solving. Oops, that's not an eraser. Okay, who cares? All right. So to solve this, we're going to first divide by 1.2, which we should get 1/2, which is the reason how we did that, and then 0.93 to the t. Right, and then to get this t down, we need to take the log of both sides. So log of 0.5 equals log of 0.93 t. That means this t can come out in front. So log of 0.5 equals t log of 0.93. Then we can divide both sides by log of 0.93. And then t equals, then we can put this in our calculator. Right, we're looking for how many years, so t is going to be a year. In years, log 0.5 divided by log 0.93. This is about 9.55. And so how many years will it take? About 9.5 years. Don't have to be exact. Okay. So you'll see a lot of word problems like this, and they're actually pretty useful in the real world versus some of those ones up in Algebra 1 that they try to do. Here is one for you to try yourself. How many years will it take to harvest half of the trees if you harvest 5% instead of 7% each year? So see if you can make the necessary adjustments to this problem in order to do that. Okay, press pause, try this on your own, and then check back for the solution. Okay, so here we just have to change this one minus 0.5, right? So every year you're keeping 95%, not 93%. So it's going to take a little bit longer. This makes sense. And then I kept this as a half instead of 0.5, and then I split it up just to show that log of 1/2 is the same as negative log 2, because this goes to 0, anything log of 1, but I just showed that just to mention it. It does not matter. It's actually not useful in this problem because you can plug this in just as easily as this. But we got 13.5, and so it's about 13.5 years, which makes sense. You want to think this through, right? If you're comparing, if you're getting rid of 7% every year and it takes 9.5 years, right? If you're only taking 5%, it should take longer to get to the half. Okay, so that's solving when the exponent is the variables in the exponent. Now we're going to solve when our equation has logs. So instead of taking logs of both sides, we're going to exponentiate each side to get rid of the log. But I think that's a little bit, that word exponentiate means we're going to turn each side of the equation into an exponent. And that's how you get rid of the log. And so, right, because this is an invisible 10, right, if we make this the exponent 2 base 10, then we do the same thing here, right, these cancel, and this is just 4x minus 3 equals 10 to the second power, which is exactly what we learned when we first learned logs. So you can also just think of it, right, when we started with problems like this, if we put our invisible 2, right, we can just rewrite this to the this equals this. So 10 squared equals 4x minus 3. So don't even think about it as exponentiating, just rewrite it like that. And so this becomes 100, and then look how easy this is to solve. It's just a nice algebra problem. So x equals 103 divided by 4. So once you rewrite it like that, x equals 25.75. And then just check this. Times 4 minus 3 is 100. Log of 100 equals 2. So just do a little check on that. All right. So here's one for you to try on your own. Press pause and then check back for the solution. Okay, hopefully you got 1.45. So here, right, this is an invisible 10, so 10 to the negative 1 equals 3 minus 2x. 10 to the negative 1 is just 1/10. You can rewrite it as a decimal. Subtract 3, divide by negative 2, and there's you get it. And then check that, multiply it by 2, subtract it from 3, and then take the log of it. You should get negative 1. Okay, and then the last types of problems we're going to do is we're going to use our laws of logarithms to condense right into logs. So here we have it expanded, but we can use our properties to turn it into 1, right? So since this is adding, we can just multiply x times x minus 3 equals 1. And then, right, this is invisible 10, so 10 to the 1 equals x times x minus 3. So then we can just solve this nice algebra equation, although not nice, right, because then we're going to have to factor 0 equals x squared minus 3x minus 10. So to solve these, two numbers that multiply to negative 10 add to negative 3, negative 5 and 2. So this is x minus 5 times x plus 2. And then set that equal to 0. That would be 0 when x is 5. That would be 0 when x is negative 2. And now we want to check both answers because sometimes they don't work. We cannot take the log of a negative number. So when we plug this negative 2 in here, this is not going to work. So this is going to be an extraneous solution. So definitely check on these ones, okay? So let's check our 5. Log of 5 is 2 plus log of 5. Does that equal 1? This is log 2 times 5, which is log 10. Yeah, 10 to the 1 equals 10. So that works. So this is a solution. And then if we tried this one, you can see log negative 2 minus 3. This is going to be log of negative 5. This is not on the domain. You cannot take the log of a negative number, so this is extraneous. And this is our only answer. Okay. That was pretty messy. This one should be easier because you're not going to have a quadratic here. Okay, so use your properties of logarithms to condense this and then solve for x. And then I think we'll be done. Time for practice. So press pause, try this on your own, and then check back for the solution. Okay, so here, right, remember because this is subtracting, the 3x goes on the bottom. 10 to the negative 2, right, invisible 10 to the negative 2. Equals that fraction, which that's 0.01, which is 0.03. When you multiply it by the 3x, divide that, you get 200. If you plug in 200 for x, you get negative 2, so that works. All right, that was a lot. So there's a lot of practice too. So just take your time on these. They can be fun, but they really do need some practice. So please spend the time to practice these. Okay, enjoy.